Welcome, curious explorers, to the start of a truly grand adventure right here in the wonderful world of science. Our story begins with a thoughtful, inquisitive child named Ray, who lived in a cozy little cottage near the edge of a great green meadow. Every morning, Ray would wake up, look out the window, and see the same magnificent, endless color stretching above him. "The sky is blue," Ray would whisper to himself. "Always blue. But why?" This was Ray's biggest question, a mystery that tugged at his imagination more than any puzzle or riddle. He knew the grass was green because it had chlorophyll, and fire was red because it was hot. But what made the entire sky blue? Determined to find the answer, Ray visited the wisest person in the meadow, Professor Spectra. Professor Spectra was an expert in light and colors, and his lab was a magical place filled with prisms, lenses, and spinning rainbows. When Ray walked in, Professor Spectra was gently polishing a magnificent prism that glittered with all the colors imaginable. "Ah, Ray, I see that curious look in your eye," Professor Spectra chuckled, setting the prism down on a soft velvet cloth. "Professor," Ray said immediately, pointing toward the window, "tell me the greatest secret of the world. Why is the sky blue?" Professor Spectra smiled. "A wonderful question, Ray. To answer it, we must first understand the magic of the sun's light." He picked up a flashlight and shone it toward a thick glass filled with clear water. The light passed straight through. "This light looks white, doesn't it?" the professor asked. "But white light is a tricky traveler. In truth, the light from the sun is made up of all the colors of the rainbow, traveling together as a team." He held up the prism, and when the flashlight beam hit it, the white light instantly split into a vibrant spectrum of colors. "Look!" Professor Spectra exclaimed. "Red, orange, yellow, green, blue, indigo, and violet, the full color crew." "Wow!" whispered Ray, mesmerized by the sharp, clean lines of color dancing on the wall. Professor Spectra explained that all these colors are different kinds of light waves, and they travel at different speeds and lengths. Think of them like cars on a superhighway. Some are long, slow trucks, and some are short, zippy race cars, he explained. The red light waves are the long, slow, steady trucks, and the blue and violet light waves are the short, fast, zippy race cars. These waves travel all the way from the sun, but before they reach your eye, they have to pass through something important: Earth's atmosphere. Professor Spectra led Ray to a special viewing station, which simulated the Earth and its thick blanket of air. "Our Earth is wrapped in a cozy, invisible layer of air. We call this the atmosphere," he said. "This atmosphere is not empty. It is full of trillions and trillions of tiny, tiny pieces of stuff. These pieces are called molecules and atoms, mostly nitrogen and oxygen. They are much, much smaller than a grain of sand. Imagine tiny, busy, bouncy balls floating everywhere, guarding the Earth," the professor instructed. Ray imagined the whole world surrounded by a busy cloud of invisible mini bouncy balls. "When the sun's light team arrives, they try to drive right through this layer of tiny balls to get to you," the professor continued. "Now, here comes the secret of the blue color. It's all about how those tiny bouncy balls react to the different cars." The professor showed a diagram with a long red line and a short blue line approaching the bouncy balls. "Remember the long, slow, red light trucks? They are so long and steady that they usually just glide right past the tiny molecules. They are rarely affected by the small obstacles. They keep traveling in a straight line, heading right for your eye. But what about the short, zippy blue race cars? The blue cars are so short and quick that they bump into the tiny molecules much more often," Professor Spectra revealed dramatically. "When the blue light waves hit the tiny molecules, they don't bounce straight back. Instead, they are scattered. They bounce off the molecule and zoom off in all different directions, like ping-pong balls flying everywhere. This special bouncing and scattering of the short blue light waves is called Rayleigh scattering, named after a very clever scientist." Professor Spectra clapped his hands loudly. "Blue light is scattered 10 times more effectively than red light. Think of it this way. The atmosphere is like a giant, super powerful filter for blue light. Because the blue light is being bounced and scattered all over the place, every part of the sky seems to have blue light shining from it. The light that travels straight to your eye comes directly from the sun, but the light that comes from the space around the sun is the scattered light. Since the blue light is the champion bouncer, it dominates the sky. Ray slowly nodded, trying to put the pieces together. So the sky isn't actually blue? Precisely, Professor Spectra cheered. The sky is just clear air, but it looks blue because it's filled with blue light that has been bounced down to us from the sun. If the Earth had no atmosphere, like the moon, the sky would always look black, even in the daytime. The sun would be a blinding white point of light, but the area around it would be dark, because nothing would be there to scatter the light. So, the blue is a gift from the tiny air molecules, making our world colorful and bright, Ray summarized. You've got it, Professor Spectra said, giving Ray a high five. You are truly a curious explorer. But Ray had a new question, inspired by the colorful light. What about sunsets, Professor? Why does the sky turn fiery red and bright orange when the sun is setting or rising? Professor Spectra loved this question. He adjusted the viewing station to simulate the sun very low on the horizon. This is where the long, slow red trucks finally get their chance to shine, he announced. When the sun is high above us at noon, the light travels through a relatively small amount of atmosphere to reach our eyes. All the colors, especially the blue, are scattered quickly, creating the bright blue midday sky. But when the sun is setting, it is very low down, practically kissing the horizon. The light has to travel through a much, much longer and thicker stretch of our atmosphere to get to us, the professor explained, showing a long, curving path on the model. Imagine the light waves now having to drive through heavy traffic. They have to push through thousands more miles of those tiny, bouncy molecules than they did at noon. All those extra molecules start to scatter the blue race cars away, and they scatter the blue light waves so much that they are almost completely filtered out. The blue light is scattered so far and wide that very little of it remains along the path that reaches your eyes. The short, zippy blue waves are exhausted from all the bouncing and vanish into the far reaches of the sky. The only waves strong enough, long enough, and steady enough to survive that long journey are the red, orange, and yellow trucks. Professor Spectra tapped the red line on his diagram. They power straight through the long atmosphere. By the time that light finally reaches our eyes, all the blue and violet light has been scattered away. We are left only with the beautiful, lingering colors of the long-wave light: red, orange, and deep yellow. That is why the evening sky puts on a warm, spectacular show just before the sun goes to sleep, the professor concluded. Ray gasped. So, the blue sky is light being scattered to us, and the red sky is light being scattered away from us. What a wonderful way to put it, Ray. You truly are a math magician. Professor Spectra corrected himself with a chuckle. A science explorer. Ray sat down, feeling a profound sense of wonder. The sky, which had once been a simple backdrop, was now a dynamic scientific masterpiece. He now understood that the color blue was a constant reminder of the invisible air that protected the planet. It was a visible sign of the tiny oxygen and nitrogen molecules working hard to scatter the sunlight for us. If those molecules suddenly stopped doing their job, our blue sky would disappear. He thought about the red trucks and the blue race cars, each playing their part perfectly in the daily show. The science of the sky was even more beautiful and mysterious than he had first imagined. It taught him a wonderful lesson. Never stop asking why. True curiosity, like the sun's light, illuminates the most amazing secrets of the world. Professor Spectra packed up his prism, putting the rainbow back into its small velvet box. Remember, Ray, every color you see, every shadow you feel, is a lesson in physics and light. The clouds are white because their water droplets are big enough to scatter all the colors equally, mixing them back into white. And sometimes the sky looks gray because there are too many large droplets blocking the light, absorbing it, and scattering it unevenly. Ray realized that the sky was constantly changing, teaching a continuous lesson about waves and particles. He thanked Professor Spectra profusely, his mind buzzing with 1,000 new, exciting questions. Now, every time he looked up, the blue wasn't just a color. It was the visible sound of tiny atoms scattering light waves. It was the result of a long journey from the sun through the Earth's gaseous bubble. He felt a deep connection to the atmosphere, to the tiny molecules he couldn't see, but whose work he could clearly admire. Ray left the lab, feeling lighter and much wiser than when he entered. He couldn't wait to share his new knowledge with everyone in the meadow. The world was full of amazing processes, happening every second, just waiting for a curious explorer to discover them. His journey to understand the sky's color had transformed him from a boy with a question into a scientist with answers. And it all started with one simple burning question. Why is the sky blue? The answer wasn't simple, but it was magnificent. It was about light waves, tiny molecules, and spectacular scattering. What an incredible adventure of science and discovery. We hope this story inspires you to be a curious explorer, just like Ray. Look up at the sky today, and remember the blue light that bounced all the way to your eyes. If you loved learning the science behind the colors of the sky, hit that like button. Share this exciting discovery with all your friends, and don't forget to subscribe to Story Crafts Kids channel for more amazing scientific adventures.